What is up, boys? What is up, boys? We are live, boys. We are live. We are live right now. We have just gone live. What is up, boys? What is up, boys? We are live, boys. We are live. We are live right now. We have just gone live. Alright, y'all, please let's start, man.
I don't wanna see the way you fall apart. Even though you told me to get back your heart, I still spin inside your orbit. Yeah. You say that I should probably start to walk away. I'm hoping that you stop and make me have to stay, cause I'm floating in your orbit. Yeah, I'm stuck in your space, just my luck. Put me away, you understand. There's nothing left to say. Pull me back, take my hand, call my name. You understand, I wanna stay. Cause I don't wanna walk away. Cause I don't wanna walk away. Cause I don't wanna walk away. Yeah, I'm stuck in your space. Just my luck. If you want me, you understand. There's nothing left to say. Pull me back, take my hand. I wanna leave. You understand, I wanna stay. Cause I don't wanna walk away. I wanna see you while you fall apart. Even though you told me to get back your heart, still spinning inside your orbit.
Alright, boys. Alright, boys.
Even though you told me to get back your heart, still spinning inside your orbit.
Alright, boys. Alright, boys. Alright, y'all, boys, bro. Welcome to today's stream, man. Welcome to today's stream. So today I'm gonna be solving some questions with divisors. I'm gonna be solving some questions with divisors. Okay. So obviously there is the naive way to get divisors, and then there's the optimal way to get divisors. So the naive way to get all divisors is just, so this is the optimal way. The naive way is to look from 1 to n, and then is to look from all numbers from 1 to n inclusive if you want to get all of the divisors of n, and that's gonna take all of n time complexity. Now this is the optimal way to get all divisors or factors of a number. So basically we're gonna loop until square root of n, because let's say we want n is 36. So 1 times, so to get 36 we have 1 times 36. So all these are all the divisors. 1, we have 2 times 36, then we have 3 times 12, then we have 4 times 9, then we have 6 times 6, then we have, what do we have? We have 9 times 4, then we have 12 times 3, then we have no, it's 2 times 18, then we have 18 times 2, and finally we have 36 into 1. Okay, so basically, as we can see, these ones and these ones are repeating, and that is why we check until square root of n. So in this case the loop is going to run only up to 6. Okay, and basically we get this from this. So our This is our I, this is our I, and this is n divided by I. Okay, this is I, and this is n divided by I. So this is 36 divided by 1. 36 divided by 1, yes, it's 36. 36 divided by 2, yes, it's 18. 36 divided by 3, yes, it's 12. 36 divided by 4, yes, it's 9. And finally, 36 divided by 6, yes, it's 6. So that means we do not need to loop anymore for all of these. We just need to loop up to 6, which is square root of 36. Or we can just write I times I less than equal to 36. So we will get 6 times 6, which is less than equal to 36. But then we will get 7 times 7, which is greater than 36. So this will stop the loop. This will stop the loop. And how do we get the divisors? If n is divisible by I with no remainder, that means that I is a divisor of n. So we're just gonna print that. And also if n divided by I, so these ones, is not equal to I, because in this case when we get to 6, so 6 is going to, so 36 divided by 6 is going to give us no remainder. So then we're going to see out 6. And then only if 36 divided by 6 does not equal 6, which in this case it does, so we're not going to push it to the array. But if it's not the same, we're going to push it to the array then, because otherwise we will have a duplicate value. Alright. And basically, let me show you guys, for example, what the factors of 36. Let me show you guys. So we're going to have all divisors of n. So this is going to give us all of the divisors of 36. Oh, don't know what this is. Okay, so that's gonna give us all the divisors of 36, which are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Now let's say we want all the divisors of 20. So that's gonna give us 1, 2, 5, 10, and 20. Okay. Okay, so that's how. And the naive way to get all divisors is just to basically run a for loop from I equals to 1, I less than equal to n, I plus plus, and then if n is divisible by I with no remainder, we're just gonna output I, and that's gonna be the naive way. That's gonna be the naive way, but this is going to take O of n time, and this is going to take O of square root of n time. So that's much faster. So for example, if you have a problem where the input is greater than 10 to the 8th and you're given 1 second of time limit, you will need to use the more optimal approach, which is square root of n, because if you use linear time on an input which is greater than 10 to the power of 8, then it's gonna give you time limit exceeded. So you can't use the naive in this case. So we're gonna say all divisors naive, and we're gonna see we get all the same, but it's slower. Okay. All right, now with that in mind, let's jump into the problems. Okay. So count divisors. Given a number n, print how many divisors it has. All right, so here's what we can do. We're gonna get n, right? We're gonna get n, we're gonna have our counter. Okay, then we're gonna use this, the optimal of all divisors, but we're also going to pass it the counter as a reference by reference, so it's gonna modify the counter inside of the function. Okay, and here each time we're just gonna say counter plus plus, and then in here also counter plus plus. All right, and that should give us the answer. So let's then see out ans, which is counter like this. We have 12, so that's 1 2 3 6 divisors. Okay, let's see then. There we go, we get 6 divisors. Let's try something else. Let's try something like 15 or something. So that's that. Okay, let's try 20. So that's all the divisors of 20. I guess let's also try 36. Why not? So that's 1 2 3 1 2 3 1 2 3. Yes, 9. Okay. So that's it for that one. Okay, that one's done and dusted. Sum of divisors. Find the sum of all divisors of n. Okay, so instead of counter, say sum. And we're just gonna say sum in here as well. And instead of, we're gonna say sum here as well. We're gonna say counter plus equals I. And here also, but not plus equals I, will be plus equals and divide I. It will be plus equals and divide I. Okay, and that should give us that. So the example is 12, and we should get 28, line 20. Okay, needs to be sum and sum. Okay, so that's 12. There we go, 28. Let's say something like 15, which should be 15 is 1 3 5, that's 9. 24, yes, 24 1 3 5, that's 9, and 15 is 24. Okay, so that's for that one. Okay, check if a number is prime. So this is, you can, by counting the number of divisors, you can also check if a number is prime or not. So for example, 15, as we can see, it has 4 divisors in total. So a number which has only 2 divisors, which is, for example, 11. So 11's only divisors are 1 and 11, and that's only 2 divisors. A number which has only 2 divisors is a prime number. So that's another way. So we can actually use the count again. We can use the count again, but this time we're gonna do something a little different. So we're gonna use the count. So this is gonna be plus plus, and this also is gonna be count plus plus. And if the count is equal to exactly 2, we're gonna see out prime, else we're gonna see out not prime. Okay, so we're gonna get 13 first. So as we can see, the only divisors are 1 and 13, so that's prime. Now let's try 14. As we can see, 14 has 4 divisors, so it's not prime. Then let's try something like, I don't know, 40, maybe 47. So that has only 1 and 47, so that's prime. Let's try 11. That's 1 and 11, and let's try 25. And that has 3 divisors, so it is not prime. Okay, that's it for that one. Alright, so that's it for that one. Next one, check if a number is composite. A number is composite if it has more than 2 divisors. So a prime number is a number which has only 2 divisors, and a composite is one that has more than 2. So we can just say greater than 2. Okay, we can say composite, and then we can say not composite. We don't really need to change that much in the code. We just need a little bit of a change. So let's say 15. So it's composite since it has more than 2 divisors. Hi bro, keep it up. Thank you, Getansh. Thank you, man. Thank you so much. I will. Thanks so much for the support, man. Thank you for the support, bro. Appreciate you, man. Okay, so that's composite. Let's try a prime number. Okay, this doesn't want to show the number. There we go. So this is a prime number, so it has 1 and 17 as divisors. So that's only 2 divisors. That's not greater than 2. So we're gonna get not composite, or this number is prime. Okay. So that's gonna be it for that one. So print the largest divisor smaller than the number itself. Okay, so basically I already have all of the divisors, right? So I already have all of the divisors here, and basically so the largest divisor is smaller than the number itself. So I do have these ones in the array. Okay, let's try to just So we're gonna get n. We're gonna get n, and then we're gonna go void. We're gonna go all divisors of n, and let's say it's smallest or something. Let's say so it's actually the largest divisor smaller than the number itself. So let's say x or something. Then we're gonna say x right there. Get rid of this, and then we can just get, so x equals to array dot size minus 1. Now I don't, let's see how for how many cases this works. Okay, so let's see if I type 17. Okay, I get 17, which is not what we want. So actually, let's set x to n, and then I'm gonna say if x, if I less than n, and if I less than n, thanks for subbing, man. Thanks for subbing. Thanks for subbing, bro. Okay, you know what? I'm gonna solve this. I'm just gonna push all of the, so I'm just gonna keep, the, so I'm gonna, okay, I'm gonna just push, so we're gonna have R1 here, and I'm gonna do R1 dot push back of I, and then I'm gonna say vector of R3 or something, and then I'm gonna, for each I in R1, I'm gonna go R2 dot push back I, and for all of these I'm also gonna go R3 dot push back R of I. So then I'm gonna assign x to R3 of R3 dot size minus 1 or something like that. Okay, or something like that, and we are still gonna see out I like this. So we're gonna see out x as well. $36. Actually, no, it has to be of 1. Hmm. Okay, I think I need to get R of 1, to be honest. Okay, there we go, 18. So largest divisor smaller than the number itself, that's 18. Then let's try 20. Okay, that's 10. Let's try 17. Okay, that's 0 though. So, okay, we're gonna let's keep that count and pass it in as well. Pass it in as well. So we're gonna keep the count. We're gonna keep the count. We don't need these. We can get rid of those. So we're gonna count plus plus, count plus plus. We're gonna get rid of this. And get rid of this like that. So that's gonna be that, and if count is equal to 2, then x is gonna be 1 since it's gonna be a prime number. So let's test it out again. Okay, did I not pass in? Okay, I didn't specify the type of it. Okay, so I deleted the array vector int. Okay, now let's say 36. There we go, we get 18. Let's say 24 or something. That's 12. Let's say 5 or something. Okay, that's 1. Perfect. Let's say maybe 17. That's 1 as well. And let's say 50. And that's 25. Okay. Okay, I did it. That's nice. All right. Okay, okay, okay. Okay, so that's it for that one. So next one is smallest divisor greater than 1. Smallest divisor greater than 1. So I'm gonna keep a vector of divisors, let's say, and we're gonna say pass this into it as well. Then I'm gonna just say vector int of divisors like this. Then I'm gonna go divisors dot pushback of I. Here I'm gonna do divisors dot pushback of R of I, and I'm gonna just set, so we don't need X anymore. So Now we're just gonna see out divisors of 1 like this, and let's say something like 20. As we can see, we get 2, so that's the smallest divisor, greater than 1. Okay, were you already good at regular coding topics before you started DSA? So listen, man, you can start DSA whenever you want. Like, even if you haven't written any sort of code before, you can just learn the basics of some language like Python or JavaScript or C++. Just learn how to write for loops, how to use variables and if statements, and then you can pretty much, that's all you need to start learning DSA. And also learn like the how to use arrays and stuff, and like you don't need, I mean, yeah, you do need, all you need to start is get like decent at regular coding topics. Yeah, so I would say, actually, I don't remember how good I was because it was a couple years ago when I started, but you can start whenever. Like, you're never gonna be ready, so might as well start as soon as possible. Just start as soon as possible. Okay, that's 2 again. Let's try 15 or something. That's 3, and let's try some prime. Okay, that's 17. Okay. Hmm. Okay. Perfect number. A number is perfect if the sum of its proper divisors equals the number. Okay. So 6 is perfect. So a proper divisor is all divisors of the number except the number itself. So that's what a proper divisor is. So I can actually write something like this. Gonna get all proper divisors or something. And I mean, I'm just gonna copy all of this. I'm just gonna copy all of this. I'm just gonna copy this. Actually, do I need to copy this? Like, I don't really need to copy this, to be honest. I mean, we can just do it like with what we've got already. I don't need these. Can just I just need a sum, and I just need a sum here like that. Can get rid of these. So that's a sum, and then I can just, so initially it's gonna be 36. So basically we're gonna have to say here, if n divided by I does not equal n, then we're gonna do sum plus equal and divide I. Okay, so in here we're just gonna do sum plus equals I. And then we're just gonna see out the ends, something like that. So all 27, okay, 34, okay, so all of the proper divisors, okay. Alright, so it does print all of the where we can say if our I does not equal n, and then we can print it. That's gonna give us all the proper divisors. There we go. And then we can just, so of its proper divisors equals a number. So we're gonna say if sum is equal to n, we're just gonna see out perfect, or else we're gonna see out imperfect, or something like that. Alright, so with the case where n is 6, it's gonna be perfect. But the case where it's 15 or something is gonna be imperfect because all of its proper divisors do not make 15. Okay, let's check numbers which are the sum of their proper divisors. Okay, we also got 14. Oh no, 28. So let's test this with 28 as well. Let's test this with 28 as well. There we go, perfect. 1, 2, 7, 14. 14 plus 14 is 28, yes. 496. Okay, this is gonna be a longer one. 496. So all of the divisors sum up, besides 496, sum up to that. And let's try something that is not perfect, like 20 or something. And that is imperfect because this is 7, 7, then this is 12, and then this is 22. Okay, guys. Okay, guys, that's gonna be it for today. Thanks to everybody who tuned in, and also to everybody who subscribed. Thanks so much for watching and subscribing. And I'm gonna see you guys tomorrow. Until then, peace out, and another day, another W. Another day, another W.